Hello gems, the grind for BITSAT 2022 is on and this is mock test number 3. If you haven't checked out the previous 2 mock tests, do check them out. I believe this series will help you a lot in boosting your confidence and giving you the right approach towards mock test. Okay, so yes, do consider following the series and let's begin with today's video. So question 1 and 2 over here, let's get straight to it. In question 1, we are given the graph of stopping potential versus the frequency of incident radiation, as you can see. So this is plotted for the most energetic photoelectron. You are supposed to tell the ratio AB by BC. Okay, you are supposed to tell what is AB by BC. AB by BC. Okay, so if you see this is theta. Okay, so if you assume that this is theta, AB by BC is nothing but tan theta, right? AB by BC is opposite upon adjacent, which is tan theta, or the slope of the graph, right? So they are asking you for the slope of this graph. Okay, some of you might directly know it by heart, well and good. But for those who don't know, every slope and intercept in this chapter comes from Einstein's photoelectric equation. Okay, you'll just have to manipulate it and you'll have to put it in the form of y equals mx plus c, and that will give you the slope and the intercept. Okay, now let's write that. So Einstein's photoelectric equation, kinetic energy of the photoelectrons is given as h nu minus the work function, right? H nu is the energy which is given by the radiation minus work function. Okay, now kinetic energy can be written in terms of stopping potential. It is E times of V. Okay, kinetic energy in terms of stopping potential. Okay, so EV, and here we'll have h nu minus phi. So V, we can write it as h by E into nu minus phi by E. Okay, and if you see, now you can compare it actually with y equals mx plus c. First of all, I brought it in this form because I want to compare it with y equals mx plus c. If you see, we have on the y-axis, we have the potential, right? We have the stopping potential. Nu, we have the frequency. This is x, right? This is x. So this is nothing but m. Okay, so m is h by e, and which is ab by bc. Okay, and that is the slope. You can even find the intercept, but that is not what is asked in the question. We are asked for the slope. AB by BC is the slope, and it is h by e. Okay, let's come to this one now. In this question, we have a train. Okay, so basically the journey of a train is divided into 3 parts. Okay, so we can picture this actually. Okay, so these are the 3 parts, suppose. Okay, so first it begins at rest. Okay, then it is accelerated with certain acceleration for 20 seconds. Okay, and it attains a speed of 40 meters per second. Okay, now it maintains that speed for the next 20 seconds. Okay, so it maintains the same speed for the next 20 seconds, this part of the journey, the second part. Okay, and in the third part, some negative acceleration is applied. Okay, so brakes are applied. Okay, and the train finally comes to rest. Okay, and it, of course, here it has a velocity of 40 meters per second, right? It begins with 40, but finally it is brought to rest by applying some brakes. Okay, you're supposed to tell what is the average velocity across this period. Okay, now average velocity, the formula is simple. It says total displacement upon total time, right? So here the displacement is in the straight direction, right? There is no coming back and forth, so we can also say total distance upon time. Okay, just terminology over here because you're not going back and forth. Okay, distance and displacement are same as long as you travel in a straight line. Okay, anyways, let's come to this. So basically we are supposed to find the total distance. If you see, the total time is already given, 20 seconds for this journey, 20 seconds for this journey, and finally 40 seconds for this journey. Okay, so 20 plus 20 plus 40, that is 80, right? So total time is already given, which is 80. We are just supposed to find all these 3 distances, s1, s2 and s3. Okay, s1, s2 and s3. Okay, so s1, first of all, in this journey it is accelerated from rest. It is accelerated to that velocity. Okay, so basically the acceleration, so this is our first part of the journey. Okay, so acceleration is change in velocity, which is 40 by 40 minus 0, which is 40, and divided by time taken, which is 20 seconds. So 2 meters per second square. This is the acceleration. Now you can easily find s1. S1 is ut plus half at square, but u is 0. So it will be half at square. Half acceleration. So that is why I found out acceleration in first place. So this is the acceleration into t square. T square, 20 square, right? For the first part of the journey, the time taken is 20 square. So 20 into 20 is 40. So 400, sorry. And that is 400. Okay, so S1 is 400. 2 and 2 will get cancelled. Okay, now coming to the second part of the journey. Second part, nothing interesting happens. Okay, your train moves with a constant velocity, right? It maintains the velocity of 40 meters per second throughout the journey. So distance is velocity into time, right? So it is as simple as that. So S2 is velocity into time. Because there is no acceleration, you can just use distance is equal to speed upon speed into time. Okay, so velocity over here is 40 and time for this journey is again 20. So 40 2s are 80, 80 and 100. Okay, 800. So S2 is 800. Okay, good. So finally we are supposed to find S3. So coming to the third part of the journey, we can find the acceleration over here. Okay, here it is retardation, right? Brakes are applied and then your train is brought to rest. So A3 will be change in velocity. So initially it is at 40 meters per second. Finally it is brought to 0. Okay, so the change is minus 40. Okay, final minus initial, right? And the time taken is 40 seconds. So acceleration is minus 1 meters per second square. Okay, now S3 can be found out as ut plus half at square. Here u is not 0, right? Initial part, third part, okay, third part of the journey, initial velocity is 40 meters per second. Okay, so ut, which is 40 into t, time taken for the journey, 40 plus half at square plus half a. I hope you are able to see this. A is acceleration over here is minus 1 and into t square, 40 square is okay, 1600. Okay, 40 is 1600 and this is half of 1600, which is 800. So again 800 over here. Okay, 1600 minus 800, which is 800. So 800, 800 and 400. So 2000, right? So 2000 by 80, what is that? 2000 by 80 or 200 by 8. So that is 8 2s are 16 and 8 5s are 40, 25 meters per second. Okay, yes, 25 meters per second is the correct choice over here. Just divided the journey into 3 parts and just found out the distances in all 3 parts. Total average velocity is total distance upon total time. As simple as that. Question 3 and 4 over here, let's get straight to it. In question 3, we are given the stress strain curve for different materials. We are supposed to make a comment on the elasticity of this materials. Elasticity basically means Young's modulus. Okay, higher the Young's modulus, higher will be the elasticity. Steel is more elastic than rubber. I hope you know that. Okay. So here the graph is of strain versus stress. Okay, Young's modulus, you'll know it as the ratio of stress by strain. Okay, so here we are supposed to find a material which has the highest Young's modulus or the highest elasticity. Okay, so slope of this graph will give us strain by stress. Okay, slope will give strain by stress, reciprocal of Young's modulus. Okay, so the one with the least slope, okay, the line with the least slope will have the highest Young's modulus. Okay, because your Young's modulus is inversely proportional to slope in this case. Okay, so if you see R makes the least angle with the x-axis, so tan theta will be least for it and hence slope will be least, hence Young's modulus will be highest for R. Okay, so tensile strength or Young's modulus of R will be the highest. Or you can also see it this way. One smart way of seeing it is you fix a value of stress. Okay, so if you fix a value of stress, you can see that the strain of R is only this much, strain of Q is this much, okay, and strain of P is the highest. Okay, so for a given stress, the highest strain is seen in P, which means Young's modulus of P is very, very less. Okay, so for a given stress, it is pulled out very much. Okay, so the strain is more, the change in dimension is more. Okay, for Q also, if you see the change in dimension is significant. For R, it's very less. Okay, as comparatively, it's less for R. Okay, so for a given stress, the strain is least for R, and hence R has the highest tensile strength. Okay, yes, option C is the correct choice over here. Let's get to this one now. Here we are given force is proportional to area, velocity, and your density to some powers. Okay, you're supposed to find the values of A, B, C. A question on dimensional analysis, right? So you can already directly, write this as A raised to A, V raised to B, and D raised to C. Here there will be a dimensionless constant when you change the proportionality to equality. So, but we are not concerned about it. We are only concerned about the dimensions. Okay, so force is mass into acceleration. So mass into acceleration, and area is L square, right? That is raised to A. Velocity is meters per second. Yes, that is LT raised to minus 1, and density is mass per volume. Okay, so mass per volume. So this is the case. Okay, so let's compare the dimensions on both sides. First of all, let's write it as m raised to c. L, if you see, it will be 2a plus b and minus 3c, right? I'm just collecting the powers from each of the terms. And t, if you see, it will be t only in this term. We have t raised to minus b. Okay, that's fine. So here we'll have m l t raised to minus 2. If you see, now let's just compare c and the power of m over here, which is 1. The power of m over here is c, here it's 1, so c is equal to 1. Okay, so we're just equating powers on both the sides. So similarly, if you see, 2a plus b minus 3c will be equal to 1. Okay, so this power equal to this. Okay, finally minus b equals minus 2, which means b is equal to 2. Okay, so c is 1, b is 2, and I think this is the correct choice over here. So C is 1, B is 2. If you can find out from here, 2A will be here, and minus 3, 1 over here, minus 1 goes to the other side, plus 2, and divide by 2, that is 1. So 1 to 1. So option A, 1 to 1 is the correct choice over here. Quite simple, just simple application of dimensional analysis. Let's move to the next question now. Question 5 and 6 over here, let's get to it. In question 5, we have a hydrogen atom, and in that hydrogen atom, an electron jumps from a bigger orbit to a smaller orbit. The radius of the smaller orbit is 1/4 of the bigger orbit. Okay, and the speed of the electron in the bigger orbit is given as v. You are supposed to tell what will be the speed of the electron in the smaller orbit. Okay, here you are supposed to know the complicated formulae of the radius and the velocity of electron in an atom. So r, the radius, is given as n square h square epsilon naught upon pi m z e square. Okay, and the velocity, I hope you know this, it is given as z e square upon 2h epsilon naught n. Okay, even if you don't know this, you are just supposed to know that r is directly proportional to n square, right? Rest all are constant. Z is 1 for hydrogen atom, so it's 1 over here, and rest also other terms are also constant. Okay, so r is directly proportional to n square. V, if you see, is inversely proportional to n. Okay, there is an inverse relation over here. Okay, so first let us take the ratio r1 by r2, okay, or r big by r small. That will be n1 by n2, right, the whole square. Okay, so similarly, let us do that for velocity. So v1 by v2, velocity in the bigger orbit divided by velocity in the smaller orbit, that will be n2 by n1, right? Inverse relation. Yes. Okay. So here we know that the radius of the smaller orbit. Okay. So r2 is the smaller. We'll consider 2 as small. Okay. So r2 is the smaller one. It's 1/4 of the bigger orbit. Okay. Or r1 is 4 times of the smaller one. So 4r by r. Right. So if r2 is r, then r1 will be 4 times of that. So 4. So this ratio is 4 over here, and n1 by n2, that is n1 by n2 squared, right? So if you take root on both the sides, n1 by n2 is nothing but 2. Okay, so we can use that over here. So v1 is the velocity in the bigger orbit, which we know as v, right? v2 is what we want to find. It's the velocity in the smaller orbit. n2 by n1, that is the reciprocal of this. Okay, so v2 will be nothing but 2 times of v, right? v2 will be nothing but 2 times of v. Okay, so option D is the correct choice over here. v2 is 2 times of v. The velocity in the smaller orbit will be twice the velocity in the bigger orbit in this case. Okay, Now let's come to question 6. Here we have a steel wire. Now the length of the steel wire is given, area of cross section is given. It stretches by the same length as that of a copper wire of length this and area of cross section this. You are supposed to find the ratio of their Young's modulus. Okay, pretty straightforward questions because Young's modulus, as you might know, is FL by A delta L. Remember this formula? We made a song out of it. Yeah, so FL by A delta L. Okay, Young's modulus is FL by A delta L. Okay, so in case of steel, we can use F1. We can use Young's modulus as Y1. Okay, the uh, things that are changing over here is the length. Okay, the length is different and the area is different. Okay, the extension is the same and we are applying a given load over here. Okay, so we can write F, this is for steel wire. Okay, similarly we can write it for copper. So Y2 will be FL2 by A2 into delta L. Okay, so the load is the same, the force that we are applying is the same, and the extension it is given stretches by the same amount, right? So the extension is also the same. Okay, so y1 by y2, y1 by y2 will be nothing but so L1 by A1, yes, and this will be y2 will be A2 by, so here you'll have L2 by A2, right? Or did I make a mistake? Yes, so here you'll have A2. Okay, it's inversely proportional to area and directly proportional to length. Okay, yes, so you are supposed to substitute the values over here. Okay, let's do that. L1 is the length of steel wire, 4.7. Then we have area of your copper wire, which is this over here. Okay, 4 into 10 to the power minus 5. Actually this will get cancelled. Okay, this factor will get cancelled, so into 4 divided by area of your steel wire. 1 is for steel. Okay, so that is 3, and that factor will get cancelled with the area of this one. Okay, and finally we have length of the copper wire. Okay, you are supposed to solve this. Here you'll get the answer as around 1.79. Okay, or that is very close to 1.8, right? 1.8 is to 1. Okay, so option D, 1.8 is to 1 is the correct choice over here. Let's move to the next questions now. Question 7 and 8 over here. In question 7, we have a ring shaped conductor which has a radius A and it is carrying a positive charge Q, and the charge Q is uniformly distributed over the ring. You are supposed to tell what is the variation of the electric field with respect to distance. Okay, so this is electric field on the y-axis and x is the distance. Okay, you are supposed to tell how will the graph look like. Okay, so what we are supposed to study is dE by dx, right? The variation of electric field with respect to distance. For that, we are supposed to know the equation, first of all, for the electric field due to such a ring. Okay, I hope you know it. If you don't, please note it down somewhere, that electric field due to a ring which carries a uniform positive charge around it. Okay, or something like this. Okay, it is given as qx upon 4 pi epsilon naught, or q upon 4 pi epsilon naught x upon x square plus a square raised to 3 by 2. Pretty much similar to your dipole. Okay, now let us take d by dx. Okay, so dE by dx, because this is what we are supposed to study, the variation of electric field, right? So q upon 4 pi epsilon naught, this is constant, right? These terms are constant, charge is constant. 1 upon 4 pi epsilon naught is also constant. Okay, so here x is the term that is varying, right? The distance is varying. Okay, it's the axial distance that is varying. Okay, so here you are supposed to apply u by v. Okay, u by v. So let's apply that. So the denominator square, so x square plus a square raised to 3 by 2 square. Okay, so if you square it, it will be multiplied. So 3 by 2 into 2, 2 and 2 will get cancelled and we'll have this. Now copy paste the denominator, so that will give us x square plus a square raised to 3 by 2, derivative of the numerator x, derivative of x 1. Now write the numerator, which is x. So I'm just applying u by v rule. Okay, and into derivative of this. Okay, derivative of that is 3 by 2 x square plus a square. 3 by 2 is 1.5. 1.5 minus 1, that is half, I guess. Okay, and again apply the chain rule. So derivative of x square, which is 2x. Okay, so 2 and 2 will get cancelled. If you see, if we put this equal to 0, so when will the electric field be maximum? Okay, the electric field is maximum if this gradient is equal to 0, right? The concept of maxima and minima, right? A certain quantity is maximum if its derivative is 0. Okay, so when the derivative becomes equal to 0, this quantity will become, the electric field will become maximum. Okay, so let's put this equal to 0. Okay, so we'll put d by dx equal to 0. Okay, so if you see, this is non-zero, right? Q is non-zero, this is also non-zero, right? So again, this term is also non-zero. Okay, because radius cannot be 0, of course. So this is some, this all three terms are some positive terms. Okay, so we can take it to the other side, multiply it by 0, that will be gone. So only term that can be 0 over here is the numerator. Okay, so that, let's write that separately. So x square plus a square raised to 3 by 2 minus, okay, then we are left with 3x square. Okay, so 3x square into x square plus a square, okay, raised to half is equal to 0. Okay, only this term can be 0, numerator of this. Okay, rest all cannot be 0. So let's simplify this. Okay, I'll take it to the other side. If you see, okay, so I can take this to the other side, so this will become like this, right? Minus 3, take it to the other side, it will become something like this. So again, this is 1.5, this is 1.5, and this is 0.5, right? So if you divide this by this, okay, this will come in the denominator, right? So 1.5 minus 1.5 minus 0.5, that will be 1. Okay, so we'll be left with something like this. Okay, I hope you are able to follow. Please rewind and watch again if you are not able to follow. Okay, so we are left with this. So now we can simplify this. It's very simple. A square will be 2x square, right? Or x square will be a square by 2, or x will be, this is the point where your electric field is maximum, because we have equated this derivative to 0, right? So it is plus or minus a by root 2. Okay, so the graph will be similar to this one, right? Because here the field becomes maximum at a by root 2. Okay, and this will correctly depict your graph. Okay, your field will become maximum at a by root 2. Okay, so yes, option C is the correct choice over here. Let's come to question number 8. Okay, here in question 7, you just had to write the formula for electric field, differentiate it, put it equal to 0, because we want to find a point where the electric field is maximum. Okay, now in question 8, we are asked for the essential condition for coherent sources. Okay, this comes by definition that two sources are coherent if they have a constant phase difference between them, right? This is the most necessary condition for coherence. Okay, or you can picture it this way, that if you have a screen, okay, we have two coherent sources, okay, or suppose we have two normal sources, okay, we don't know if they are coherent or not. Okay, so we have this ray meeting at this point. Okay, so if they are not coherent, okay, if they don't have a constant phase difference, okay, if they don't, if the phase difference between these two lines, between these two waves is changing with time, okay, what will happen, this will become bright at some point of time, it will become dark, it will become bright, it will become dark. Okay, if the phase difference is varying between the two, and this is what we don't want if we want to study an interference or a diffraction pattern, right? So for two coherent sources, the must condition is that they should have a constant phase difference, okay, so that the pattern that they produce does not vary with time, right? The bright does not become dark after some time. Okay, so the pattern should not change with time, and the two coherent sources must have a constant phase difference between them. Okay, now let's move to the next question. So question 9 and 10 over here. In question 9, we have an unpolarized light of intensity I naught passing through the first polaroid. Its intensity becomes I dash. Okay, then it will pass, this light will pass through this second polaroid, and finally the intensity becomes I double dash. You are supposed to find the value of I double dash if the angle between the pass axis of the two polaroids is 60 degrees. Okay, it's quite simple. because first of all, let's find I dash. I dash will be simply I naught by 2, right? Because whenever an unpolarized light passes through a Polaroid, the intensity becomes I naught by 2. So the intensity obtained over here will be half of the initial intensity. Okay, now we are supposed to find I double dash. I double dash, you can simply find it using Malu's law. So I double dash will be given as I dash into cos square phi, right? The intensity that is incoming times cos square phi, the angle between the two polarities. Phi is the angle between the two polarities. Now I dash is nothing but I naught by 2, right? We are supposed to express the answer in terms of I naught. So yes, then cos of 60. Cos of 60 is half, sin 30 half, cos 60 half, and half squared. Okay, so that will be 1 by 4. And here the answer will be I naught by 8. Okay, so option D, I naught by 8 is the correct choice over here. Okay, now let's come to question 10. So here we are told let the binding energy per nucleon for nucleus be denoted by this, and radius is denoted by small r. So you are given the mass number of A and B, this and this respectively. You are supposed to tell the relationship between their radius and binding energy per nucleon. Okay, so it's actually very simple. The radius basically is given as r naught to the power r naught equals, okay, wait, radius equals r naught into a to the power 1/3. Okay, so or you can directly say r is proportional to a to the power 1/3, where a is the mass number. Okay, so r a, radius of a, divided by radius of b will be nothing but the atomic mass of a, which is 64 atom, divided by atomic mass of b whole raised to 1/3, right? So it's 1/3 of the power of your atomic mass numbers. Okay, so this is also simple because 64 is 4 to the power 3 and 125 is 5 to the power 3. Okay, so this simply becomes 4 by 5. Okay, so RA by RB, or this ratio is around 0.8. Okay, so you can make a guess that RB is bigger than RA, right? Because the ratio is 0.8, it's less than 1, so the denominator is bigger than the numerator. Okay, so yes, RB is greater than RA, or this one is true. Yes, this is also true. Okay, or RB is bigger than RA, or RB is bigger than RA. So option A, C, or D. Option B is incorrect. Now let's come to binding energy. Okay, binding energy, if you see, you are supposed to remember the graph for binding energy per nucleon. Okay, or generally in your mind you should have a basic representation of it. So it somewhat looks like this. So it goes this way. It's highest for iron, which is around 56, and then it goes on decreasing. Okay, now we have mass numbers in the range 64, which is over here, and finally we have 125, which will be around here. Okay, so after 56 it just goes downhill, right? It goes on decreasing. Okay, so 64 will have a higher binding energy than 125, right? So the binding energy of A per nucleon. Okay, so binding energy of A per nucleon will be bigger than 125, the mass number 125, because after 56 it just goes on decreasing. Okay, so the smaller one will have the higher binding energy. So the binding energy of A is bigger than B. Where does it say that? So again, see, if you see, binding energy of B is greater, which is incorrect. Option D is correct over here. So this is already correct, and binding energy of A is bigger than B. Okay, this is also incorrect if you see. Yeah, so let's move to the next question now. So question 11 and 12 over here, let's get to it. In question 11, we have a current carrying wire. It is carrying a current of 4 amperes. Its area of cross section is given, and the number of free electrons per unit volume is also given. You are supposed to find the drift speed of this electrons. Okay, quite a straightforward question, because current can be written as NEA times VD, right? N number of free electrons, E is electronic charge, A area, VD is the drift speed. So drift speed will be simply I upon NEA. I is 4 amperes divided by NEA. N is 12 into 10 to the power 28. E is 1.6 into 10 to the power minus 19 into area, which is 2 millimeter square. So 2 into 10 to the power minus 6, right? 2 millimeter square. So yes, 10 to the power minus 6. Okay, so 4 3s are 12, and here we'll have 3 into 2 into 1.6, and here the power of 10. so 10 to the power 9, okay, and plus 3 will go on top as minus 3, okay, and this, if you see, is 10 to the power minus 3 upon 9.6. So upon 100 will be, upon 10 would have been zero point 0.1, so this would have become 10 to the power minus 4, okay. So 10 to the power minus 4, this will be greater than something very close to 10 to the power minus 4, okay. So yes, option C, 1.04 into 10 to the power minus 4 will be the correct choice over here, okay. Now we have a block of this much mass at a temperature of 150 degrees Celsius. You are going to drop it in a calorimeter. It has a water equivalent of this, so that basically helps in absorbing the heat, and it also contains some water, 150 cc, which is cubic centimeter, okay. So that much amount of water at 27 degrees Celsius, okay. You are told that the final temperature of the system along with the block, which is dropped in the calorimeter, the block and the water, gains a temperature of 40 degrees Celsius. You are supposed to tell what is the specific heat capacity of the metal, okay, or the block over here, okay, the metal block, okay. So first of all, we'll write Q equals mc delta T for the block. This is the amount of heat that is lost by the block, right? We'll also write Q equals mc delta T for the calorimeter. That is the amount of heat absorbed by the calorimeter. These two heats will be equal, assuming that there is no loss to the surrounding, right? So this, for the block, you can write it as m, 0.2 kgs. Let's express everything in grams because we have everything in cgs, right? 0.2 kg is 200 grams. C is, if you see C is something which we want to find, heat capacity of the block, into delta T. Delta T is change in temperature, so 150, and finally it comes to 40, right? Finally the system comes to 40 degrees Celsius. So the change over here is 110, right? Now again, let's write this for the calorimeter. Calorimeter mass, if you see, first of all, water equivalent. So express this in grams into 10 to the power 3, so 25 grams, right? Plus we have 150 cubic centimeter of water. So mass of water will be density into volume. Density of water in CGS unit 1, volume is 150. So 150 cc basically means 150 centimeter cube, okay. So this will give us 150 grams, okay. So 150 grams plus 25 grams, that I'll directly write it as 175, okay. And C of water is 1, right? Specific is heat capacity of water in CGS is 1. Delta T, okay. Delta T, change in temperature. So from 27 it went to 40, so that is 30, okay. So you will have to equate this to now 200 into, or I can write this as 22 and 3 zeros, right? 11 twos are 22 and 3 zeros. C is equal to 175 into 30. Okay, C is equal to 175 into 13 upon 2200. Okay, if you see, these are very close to each other, right? If this was 200 and this was 10, it would have been 200 with those many number of zeros. Yes, 3 number of zeros. Okay, so these terms are very much close to each other. So I think the correct answer over here should be 0.1. Okay, let me check that. You just have to calculate it. Yes, the correct answer over here is 0.1. Okay, so this will be again around this only, 22,000. So it will be 2,200. Okay, basically 1 zero less. Okay, so yeah, that's the correct choice over here. Let's move to the next question. Question 13 and 14 over here. In question 13, we are given the expression for electric field in a region. We are supposed to predict the expression for potential. Okay, quite simple. You are just supposed to know the relationship between your electric field and potential. Basically, electric field is minus dV by dx, right? So if it's in the x direction, okay, here it's only in the x direction. So let's find out potential. Potential will be the integral of this now. So minus integral of Ex dx, right? So simply the integral of this, the integral of your E dx will give you the potential in that region, right? So this will give you the potential. Now the integral, if you see, it is m by x cube. M is a constant over here, so it will come out, and dx upon x cube. Okay, you can just imagine this as x to the power minus 3 dx. Okay, you can use the n plus 1 rule. Okay, so that will give you 3 will come as x to the power n plus 1, that is x to the power minus 2, divided by, will go in the denominator as x to the power minus 2, and upon n plus 1. Upon n plus 1 is again minus 2, so this will become plus m uh, upon 2x square, okay, which is option A. Simple integration over here, and that gives you your answer. Now let's come to this question. Let's imagine this. We have a ball is being projected from a 70-meter tall building. Okay, it is projected at an angle of 30 degrees with respect to horizontal. Okay, and with a speed of 50 meters per second. Okay, so you are supposed to tell what is the time taken by this ball to reach ground. Okay, it will follow a trajectory like that. So what is the time taken by the ball to reach the ground? Actually, you can directly apply s is equal to ut plus half a t square, and u being your s being this distance, right? It is the displacement between the initial point and the final, the shortest distance, right? You are not worried about this. Okay, so the shortest distance, and you can directly find your answer from there. Okay, we'll do it in a more simpler way. Okay, first of all, we'll find the time for the projectile motion. So first of all, the ball is being projected like this, so it will complete the projectile motion and then it will fall downwards, right? So first of all, let's find out the time t1 which is required for the projectile motion, and the time is given as 2u sine theta by g, right? This is the time of flight. So 2u, u is 50, so 2 into 50 100, sine of 30 degrees, sine 30 half, g is again 10, so this and this will get cancelled, and we have 5 seconds. So 5 seconds is the time taken by the ball to complete the projectile motion. Okay, now actually we can break this into two components. Here 50 sine 50 cos 30, adjacent to theta is cos theta, so 50 cos 30 we are not worried about it actually, and we are worried about the sine component. Okay, so 50 sine 30, 50 into sine 30 is half, so that makes it 25 meters per second. Okay, so the vertical component is 25 meters per second. Okay, so it will go on decreasing at this point. At the highest point it becomes 0, right, and then it will go on increasing in the downward direction. Finally it will become like this, right, and here the value will be 25 meters per second. Okay, in the downward direction. That's just the mirror image of this. Okay, so after completing the projectile motion, whereas this horizontal component will continue in the same direction, right? So we have 25 meters per second in the downward direction, and we can apply now what can we use to find time? S is equal to ut plus half at square. Okay, so s is 70. Okay, we'll consider the downward direction as positive because everything is in the downward direction, if you see. So s is plus 70, ut acceleration, sorry, u is initial velocity. Here when we begin over here, we have the initial velocity of 25. Okay, that is 50 sine 30. Okay, so 25 t ut plus half at square. Okay, this is the time for the ball taken from here to here. Okay, here to here. After completing the projectile, the time to fall. Okay, so half a acceleration is 10. Okay, and t square again. So this will become 5. We can actually cancel 5. So we have 5t square plus 25t minus 70 equals 0. T square plus 5t minus I think it's 14, right? 14 5 is 70. Okay, so this gives us 0. So 14 is 7 2s are 7 2s are, and I think it's plus 7 minus 2. So plus 7, this cannot be equal to 0. Time cannot be negative, so this is equal to 0. So this gives us t2 as 2 seconds. Okay, this is the time taken by the ball to fall from here to the ground. Okay, so 2 seconds is the time from here to here, and 5 seconds for the projectile motion. So the total time is 5 plus 2, which is 7 seconds. Okay, it's not 5 seconds because in 5 seconds it just completes the projectile in the next 2 seconds it falls down to the ground. Okay, so 5 plus 2, 7 seconds is the total time taken by the ball to fall. Anyways, you could have directly use s is equal to ut plus half at square over the entire journey. That would have given you the same answer. Okay, yeah, that's your answer over there. Let's move to the next question. Question 15 and 16 over here. In question 15, we have some combination of capacitors X, Y, Z. The values of the capacitor are given. You are supposed to tell what is the equivalent between A and B. Okay, this is one of the concepts that I taught in concept capsule if you want to go back and watch it. Okay, so here if you see, it's very simple to solve this question actually. Okay, first of all, you can't make out whether they are in series or parallel. So the concept over here is to look out for the potential. Okay, so here the potential, let's assume it to be A, so here also it will be A. Okay, so as long as there is no element, resistor, capacitor, inductor or any other element across the conductor, the potential will not fall. So if the potential over here is A, so here also, here also, here also, here it will be A. Okay, so if here the potential is B, here also, here also, here also, till here it will be B. Okay, no potential falls across the wire basically. Okay, so if you see X is connected between A and B, Y is also connected between A and B, Z is also connected between A and B. Okay, so here the connection is somewhat like this. Okay, here is point A and here is we have point B. Okay, the connection is basically parallel connections. Okay, so if you see X is connected between A and B, Y is also connected between A and B, and Z is also connected between A and B. So it's the parallel combination of these three. So equivalent will be nothing but C1 plus C2 plus C3. So 3 plus 3, which is 6 microfarad. Okay, so option A, 6 microfarad is the correct choice over here. You are just supposed to decode that these three are in parallel combination. Okay, so the work done, now question number 16, the work done in blowing a soap bubble of surface tension this from this much radius to 5 centimeter radius. Okay, so the work done basically will be change in surface energy. So change in surface energy, we can call it delta U. Okay, so change in surface energy. So surface energy is basically given as T into delta A. Okay, T into delta A. So now the surface tension remains the same. There is change in area, right? Area is the surface area of your soap bubble. Okay, so it will be 4 pi r square, the final radius, which is 5 centimeters square, so 25 into 10 to the power minus 4. That also I'll have to write minus, okay, 4 pi r square, the initial radius. Okay, so 4 pi, okay, I can actually take 4 pi common first only, 4 pi, so this common, and r square minus this r square, right? So 2 square, which is 4 into 10 to the power minus 4. Now remember, very important thing, that this is a soap bubble and a soap bubble has two surfaces, inner and outer, so you'll have to multiply the surface area by 2. Okay, please remember it. It's not there for just liquid bubbles. For soap bubble, it's the special case, right? You have two surfaces, so you'll have to multiply it by 2. Okay, so 0.06 into, you'll have to calculate this now, 0.06 into 4 into pi into, this is 21 into 2. Okay, so the answer of this will be the answer over here. I think once you calculate it, you'll get it around 3.168. Yes, that's the correct choice over here. Let's move to the next question now. So question 17 and 18 over here. In question 17, we are given that the sum of the magnitude of two forces acting on a point is 16 Newton. So suppose the forces are A and B, their magnitude are A and B. So A plus B is 16. This is what is given. The resultant of this is perpendicular to the smaller force. Suppose A is the smaller force over here. So their resultant is perpendicular to the, so this is the resultant, is perpendicular to the smaller force A. Okay, now you can easily draw B using your triangle law. So B will be along this direction, right? So A plus B is equal to C. Okay, just use your triangle law over here. So going from here to here and then here to here is same as going from here to here. Okay, basic application of triangle law. So B here you can also write it as 16 minus A. First of all, let me tell you why we are doing this. So we are supposed to find the magnitude of the smaller force. It is given that the magnitude of the resultant is 8 newtons. Okay, so here first of all you can apply Pythagoras theorem. So a square plus r square. Okay, this corresponds to the magnitude. Okay, so a square plus r square is equal to b square, right? A square plus r square is equal to b square. Okay, now we want to find the magnitude of the smaller force. The smaller force in our case was a, right? So a, so we want to put everything in terms of a. Okay, we don't want this b in our answer, so we want to put it as 16 minus a. Okay, now substitute that. So a square, r has a magnitude of 8, so this length is 8. Okay, so 8 square is 64, and we have b as 16 minus a the whole square. So 16 minus a the whole square, so 16 square 256 minus 2ab, which is 32a, and a square plus a square, right? So a square and a square will get cancelled, and we have 32a is equal to 256 minus 64, 250 minus 60, 190, 190 and 192. Yes, so 192 and 32. Okay, I think these are divisible. Okay, 8 4s are 32, 8 2s are 16, 17, 18, 19, 8 4s are 32 again, 4 6s are 24. Okay, so 6 are. Okay, so the answer over here is 6 newtons. Okay, so the magnitude of the smaller force is 6 newtons. You can also find the magnitude of the bigger force. A plus b is 16, so b will be 10, right? This is 6, so b will be of course 10. Let's come to this one. We have a circuit of this kind. Okay, these 2 points are centered or earth. Okay, you are supposed to tell what is the current flowing in the circuit. Whenever such type of thing is given, you are just supposed to use KVL, right? If you see here, the potential across this point and this point is the same, right? They are centered or earth, so the potential difference across these 2 points is 0. Okay, so we'll go around this loop, put it equal to 0, because there is no potential difference over here and here. Here and here the potential is the same. Okay, so we'll start from here. We'll have minus 4i, right? The current is flowing like this, I. So minus 4i, then plus 10, negative to positive, plus 10. If you can see, these all 3 resistors are in series. Okay, so 10 I will be simply V by R. V is 10 and it will split along this 3. So sum of this 3 will be 9. 9 plus 6 is 15, right? Somewhat like this. Okay. Okay, let's do it by Kirchhoff's law. Minus 4i plus 10 minus 5i minus 6i is equal to 0. Okay, no potential difference here and here. So it's 0. So 10 you'll have minus again 15i, right? So I is nothing but 10 by 15 or 2 by 3, right? 2 by 3 is 0.67. Option A is the correct choice over here. Okay, yeah, let's move to the next question now. So question 19 and 20 over here. In question 19, you are given the age length of cuboid. You are supposed to tell the volume of the cuboid. Okay, what a silly question, right? But then you see the options. Okay, how is this different from this? And this shall click you that this is a concept based question on the concept of your significant figures. Okay, so yes, you are supposed to use significant figures over here, and volume will be length into breadth into height. Okay, so first initially it's simple, just carry out the procedure. So 1.2 into 1.5 into 1.8. So 1.2, so 1 into 1.5, that is 1.5. 1.5 into 2 is 0 0.3, 0 0.3, 1.8. 1.8 into 1.8. Yeah, mental math. Okay, so 1.8, 18 square is 324, so 3.24. Okay, now you are supposed to decide the number of significant figures. The rule in multiplication and division is least number of significant figures. In addition and subtraction, the rule is to maintain least number of decimal places. Here you are supposed to maintain least number of significant figures. If you see in your in the quantities that you multiplied, the number of significant figures was 1 2, right? 1 2. So you here also you are supposed to maintain 2 significant figures, which is 3.2 centimeter cube. Okay, so option C is the correct choice over here. Okay, now let's come to this one. We are given that the electrostatic force between two positively charged particles is this. Okay, then you are supposed to tell how many electrons are missing. Basically, you'll use Coulomb's law. Okay, first of all, you'll write F is equal to K Q1 Q2 by, here the charge is identical, so QQ by R square. Okay, they are separated by this distance. Okay, the force is given. Now finally we'll put this Q equals N. Okay, I'm not substituting here, it will make it too complicated. Okay, so here we have K Q square by R square, and here we have F. Okay, now let's substitute the values. F is this, okay, K is 1 upon 4 pi epsilon naught, which is 9 into 10 to the power 9 into Q square. Fine, this is Q square upon R square, which is 25 into 10 to the power minus 20. Okay, so Q square will be 3.7 into 10 to the power 9. Okay, and here we'll have 25. Okay, 25 into 10 to the power minus 20 upon, what do we have, 9 into 10 to the power 9. Okay, so if you see, we have Q square as, so suppose this was around 4. Okay, first of all, let's consider the powers of 10. Here we'll have 10 to the power minus 18, right, and minus 20, that is minus 38. Okay, so this is 10 to the power minus 38. Okay, so if you see this, if this was 4, okay, this was 4, then if we had to take the root on both the sides, okay, because this is Q square and this was 4, so that will give us 2 into this will be 5, and here we'll have root of that is 3. Okay, and we had 10 to the power minus 38, which is 10 to the power minus 90, right, root of that. Okay, so basically my thought process behind this was to bring it closer. Okay, if you see, this is 10 by 3, right, 10 by 3 is 3.33, right, so 3.33 into 10 to the power minus 90, which is very much close to 3.2, right. If we had suppose 3.7 in place of our 2, we changed it to 4, right, so that we get a perfect root. So in that place, suppose we had 3.7, so the root would have been something lesser, right, so the answer would have been something lesser, which is this, around this, because this is a closer multiple of 1.6 into 10 to the power minus 19, right. Our answer should be a multiple of 1.6 into 10 to the power minus 19, at least a close approximation. So Q equals NE. Finally, N, here Q, we know that it is 3.2. We'll take it as 3.2 because it's the closest multiple to this answer, okay, which has come through certain assumptions. So N is here. So finally, you can see that this is 2 times. Okay, we only manipulated it, so this is 2 times. So the number of electrons missing are 2. Okay, that's why it's positive, right? This many electrons are missing, and the electrons are missing because it is a positive charge over here. Okay, so I think that was simple. Let's move to the next question now. So question 21 and 22 over here. In 21, we have a narrow beam of proton and neutron which have the same linear momentum. Okay, now these two particles enter the region of magnetic field where the magnetic field is perpendicular to the direction of momentum. Okay, momentum is basically the direction of velocity, right? So if they are moving this way, the direction of the magnetic field is inward or outward. Okay, so basically perpendicular. Okay, you are supposed to find the ratio of the circular paths described by them. Okay, it's quite simple. If you see the radius of the path of the circular path, when a charged particle is moving in a magnetic field, it is given as mv by qb, right? If you see, mv is nothing but momentum, right? So momentum by qb. If you see, we have a proton and a neutron. Okay, if you see, they have told us in the question that they have the same momentum. So mv, the product of mass into velocity, is same for both, right? So also, if you see, the magnetic field is uniform, it's same for both. Okay, they are released in the, or they are moving or propagating in the same magnetic field, so B is same for both, right? Q, if you see, charge of proton and neutron are the same. They all only differ in number of neutron, right? Deuteron basically has one extra neutron. Okay, proton is just one proton, and deuteron has one proton and one neutron. That's the only difference over there. Okay, but neutron does not contribute to charge, right? The charge of proton is 1.6 into 10 to the power minus 19, and that of deuteron is also same, which is 1.6 into 10 to the power minus 19. So if you see, this is same for both. Momentum is same, charge is same, B magnetic field which is given is same. Okay, so the radius is same for both. Okay, so the ratio of the radius is 1:1. This is because they had the same angular momentum. If they didn't have the same angular momentum, sorry, same linear momentum, right? So if they didn't have, you had to consider the mass. Okay, mass, neutron contributes to the mass. Okay, so that you had to keep in mind. Okay, here they had same momentum, so that's why the question simplified out. Okay, so now let's come to this one, a solenoid of length. So basically you are given the description of a solenoid, its length, radius, number of turns, okay, the current which it is carrying. Now electron is moving along the axis of this solenoid. Okay, so electron is moving along its axis. Okay, you are supposed to tell the velocity of the electron is also given. You are supposed to tell the force experienced by this electron. Okay, so basically it's quite simple. You don't have to do anything actually. F equals qv cross b, right? Or qvb sin theta, v cross b. Okay, so if you see what is the angle between v and b, okay, that will give you your answer. Answer is 0. Yes. So if you see your velocity of the electron is along this direction, and the magnetic field along the axis, okay, inside the solenoid is along the axis, right? So v and b are in the same direction, so v cross b is 0, vb sin 0, sin 0 is 0, right? So of course the force experienced is 0. Okay, you didn't have to run your pen on that. Okay, so let's move to the next question. So question 23 and 24 over here. In 23 we are asked, what can a magnetic field do? Can it increase the speed of the particle? Can it accelerate the particle? Means the same, does it? Or do both or neither? Okay, so basically your magnetic field can put a moving particle into uniform circular motion, right? Mind you, it's uniform circular motion. Okay, suppose we have a magnetic field like this, and we have a particle which is moving with velocity v in this direction. It will perform uniform circular motion. Okay, so if you see, every uniform circular motion is an accelerated motion. Okay, I hope you know the concept of circular motion, because if you see, this particle is changing direction at every instant of time. Okay, so this is the circular motion. So if you see, okay, at this point the velocity is like this, at this point the velocity becomes like this, at this point the velocity is like this. So at every instant of time the velocity is changing its direction, right? What is acceleration? Acceleration is change in velocity, and velocity is a vector, right? Or even if the direction of velocity changes, velocity changes, so there is acceleration. Okay, so yes, magnetic field can accelerate the particle in uniform circular motion, right? The only difference is the acceleration only changes the velocity of the particle. Okay, sorry, it changes the velocity, the direction of the velocity. Okay, it does not change the magnitude of the velocity, which is the speed. Okay, so your particle will not gain speed, will not get kinetic energy. Okay, it will only be accelerated by changing its velocity. Okay, I hope that's making sense. Okay, so your magnetic field can accelerate the particle, but the acceleration only changes the direction of the velocity. Okay, so now let's come to this question. Here we are told that susceptibility of a paramagnetic substance at this much temperature is this. You are supposed to tell the temperature at which your susceptibility will increase to this. Okay, quite a rare question from magnetism and matter. Okay, usually questions from this chapter are not being asked. Okay, but anyways, let's do it. It's quite simple. So by Curie's law, your susceptibility is actually inversely proportional to absolute temperature. Okay, it's basically susceptibility is Curie's constant by T, right? So susceptibility is inversely proportional to temperature for paramagnetic substances. Okay, so you can directly use the relation, take the ratio will be T2 by T1, right? Inverse relation. Okay, now we are given the different susceptibilities. For one, it is 1.2 into 10 to the power minus 5, and it changes to 1.8 into 10 to the power minus 5. Okay, now T2 is the temperature in the second case, T1 is the temperature initially, which is for this case, which is 300. Okay, so this will become 300 into this, and this will get cancelled. 2 za 3 za, right? 6, and here we'll have this 100 and into 2, that is 200. So option C, 200 kelvins is the correct choice over here. Okay, simple question. Let's move to the next question. Question number 25 and 26 over here. In question 25, we have a thermodynamics process in which we change the pressure of a fixed mass of a gas, and it is done in such a manner that the gas releases 20 joule of heat and 8 joule of work is to be done on the gas. You are supposed to tell what is the final internal energy of the gas. Okay, it is given that the initial internal energy was 30 joules. Okay, so basically we are supposed to use the first law of thermodynamics, which is Q equals U plus W, right? The amount of heat supplied will be split up between internal energy and the work done. Okay, so basically conservation of energy, right? So heat, if you see, the heat is released, 20 joule of heat is released. So when heat is released, it is negative, right? So minus 20 joules over here. Okay, internal energy, the change will write in the internal energy. Basically it's changing over here due to the exchange of heat. Okay, so we can write the change as U final minus U initial, right? So U initial, if you see, is 30 joules. Okay, so U final minus U initial. So initially it was 30 joules plus if you see, 8 joule of work is to be done on the gas. Okay, so you need to do work on the gas, which is negative. So this is minus 8, right? Because work done by the gas, we can use the gas for our profit. So that way work done by the gas is positive, but work done on the gas, we have to do work on the gas, so in order to make profit, so that is negative. Okay, so work done by the gas is positive, on the gas is negative. Okay, so work done on the gas negative. Okay, negative 8. So coming back, so this, if we take this 8 over here, so 8 minus 20 minus 12, so U final minus 30, so this will be U final will be 30 minus 12, that is 18 joules. Okay, so option C, 18 joules is the correct choice over here. Yes. So let's come to this one. This is pretty simple. Okay, we are given the equation of a wave. We are asked for the wave velocity. Wave velocity, as you might know, the simple formula for wave velocity is omega by k. Okay, so here you are just supposed to know to find omega and k. Okay, omega is basically the coefficient of t and k is the coefficient of x. Pi by 2 is a common factor, so even if you divide, it is going to cancel out. So you can just consider that bracket. So omega is the coefficient of t, which is 50, divided by the coefficient of x, k, which is 1. Okay, so it is 50 in whatever units it was given. Okay, 50 units of distance by units of time. Okay, or meters per second, simple way. Okay, let's move to the final few questions for the day now. Question number 27 and 28 over here. In question 27, we are given the RMS velocity of oxygen molecule at 16 degrees Celsius is this. You are supposed to tell what will be the RMS velocity of hydrogen molecule at this temperature. Okay, so basically RMS velocity is given as under root 3 RT by M, where M is the molecular weight and D is the temperature. R is constant. Okay, so here the velocity of, suppose, hydrogen molecule divided by velocity of oxygen molecule. Okay, so this ratio will be simply, if you see, it's your velocity is directly proportional, Vrms is directly proportional to the root of temperature upon, and it's inversely proportional to the molecular mass. So here we'll have the temperature of hydrogen gas, we have it as 127, put it in Kelvin. So that is 400, okay, divided by the mass of your hydrogen, right? It's inversely proportional to mass, so inversely proportional to the molecular mass, which is 2, not 1. Molecular mass H2, okay, so 2 times, okay. Then we'll have inverse relation again here, mass of oxygen. So mass of oxygen is 32, okay, molecular mass not 16, 32 O2, okay. And temperature, what is the temperature? 16, 16, 289, okay. So 273 plus 16, 289, okay. Now again this is hectic. Now here it's the RMS velocity of oxygen is given 474, okay. Now again it's hectic to solve, okay, but you'll have to solve, okay. So here, like for example, this and this you can get, you can cancel it, okay. 400 is a perfect root, no need to cancel that. 2 and this you can cancel, that will come out as 20 into 16. I think no need to cancel at all. 289 is 17, I guess, and this is 474, okay. So basically if you calculate this, I think the answer will be pretty much close to option C, okay. Yes, I think the answer should be close to option C, okay. So once you solve this, the correct answer over here is option C. This will be 4, okay. Yes. Now let's come to question number 28. You are supposed to determine the current in the 2 ohm resistor. This current you are supposed to find. We'll name it as I1, suppose, okay. So you are supposed to tell what is the current in the 2 ohm resistor, okay. And it is given that in steady state. State basically means when your capacitor is fully charged. When your capacitor is fully charged, the current will not flow in that branch in which the capacitor is connected, okay. So here the capacitor will store its charge and current will not flow in this branch, okay. So it will just act like a open circuit. It's good for nothing, okay. It's an open circuit over here, so the current will only flow in these 2 branches, okay. So it will flow like this and these 2 branches, and again like this, okay. It will not flow in the branch that includes the capacitor, okay. Now the circuit becomes very simple. If you see 3 and 2 in parallel, okay, and that in series with 2.8, 3 and 2 in parallel, that is product upon sum. So 3 2s are 6, 6 by 5 is 1.2, so 1.2, and this is 4, 4 and 6 in 4 and 6, you have to find the current. I is V by R, V by R is 4, okay. So this is, I hope you are following. So R effective, if you see here, 3 and 2 in parallel is 1.2, 1.2 plus 2.8 is 4 ohms, okay. And I is V by R, so V by R, so this is the current that is coming out from the battery, okay. So this I guess is 3 by 2, 1.5 amps. So 1.5 amps is the current that is coming out from here. We are supposed to find I1. I1 is simply given as, if you know current divider rule, okay, you can use that, or you can use I1 R1 is equal to I2 R2, okay, and I2 you can write as I minus I1, okay. So everything will be in terms of I and I1. You know I, you are just supposed to find I1, okay. Or you can use current divider, which says total current is 1.5 into the resistance in the opposite branch, which is 3, upon the sum of the resistors in 2 branch, okay. So total current into the resistor in the opposite branch, okay, upon the sum of the 2 resistors, okay. So 5, here you'll have 0.3 and it's 0.9 amperes, okay. So option C, 0.9 amperes is the correct choice over here. Over to the final 2 questions for the day. Question 29 and question 30 over here. In question 29, you are supposed to tell frequency is proportional to, okay. So what is frequency proportional to in this kind of a system, okay. So it's a little bit tricky, okay. First you'll have to tell me, okay, these are your homework questions first of all. So only tell me what are this 2 springs in. Are they in series combination or are they in parallel combination, okay. Do let me know the answers in the comment section below. The correct answer will be receiving a heart from me, okay. What type of combination is this? Is this series type of combination or is this parallel type of combination? Yes, it's one among them. Okay, and this is question number 30. And if you are able to make out what type of combination this is, you will easily be able to answer this question. Okay, now this is question 30. It's also simple. It's based on the concept of amplitude modulation from communication devices. Okay, so that chapter is also important for your BITSAT. Okay, especially in the new years, upcoming years, questions will be asked from this chapter and semiconductors. Okay, in the recent papers you'll see at least 1 or 2 questions from semiconductor and communication devices. Okay, so do try that out too. Do let me know the answers in the comment section. That's all from today's video. If you wish to join the grind, consider subscribing. I'll see you soon in the next video. Till then, keep enjoying physics.